Balancing equations. There are 5 different types of reactions. We have synthesis reactions, decomposition, double replacement, single replacement, and combustion reactions. Synthesis reactions. In a synthesis reaction, reactants combine to form a single product, and the general formula is A plus B yields AB. Decomposition reactions. In a decomposition reaction, a single compound breaks down into 2 or more elements, and the general formula is AB yields A plus B. Single replacement reactions, also known as single displacement, and the general formula is AB plus C yields AC plus B. Double replacement reactions, also known as double displacement, and the general formula is AB plus CD yields AD plus CB. Combustion reactions. In a combustion reaction, the reactants will always consist of a hydrocarbon and oxygen, and the products will always be carbon dioxide and water. The general formula is CxHy plus O2 yields CO2 plus H2O. Why do you have to balance equations? It is important for equations to be balanced in order to follow the law of conservation of mass. The law of conservation of mass states that atoms are not created or destroyed during a chemical reaction. So therefore, the same number of atoms of each element must be present on both sides of the equation. How do you balance chemical equations? To balance chemical equations, you can add coefficients in front of the chemical formula, but you can't add or change the subscript. Step 1, you need to figure out how many atoms are present of each element on both sides. So in our example, on the reactant side we have 1 Mg and 2 Ns, and on the product side we have 3 Mgs and 2 Ns. And step 2 says we need to find an element that is not equal on both sides. In this case, it is Mg. Step 3, we need to add a coefficient that will make that element equal on both sides. And we added a 3 on the reactant side in front of the Mg, and now our equation is balanced. It's okay if you're still stuck, we're going to do a few more examples. Okay, so our first example is H2 plus O2 yields H2O, and this is an example of a synthesis reaction because we have A plus B yields AB. And our step 1 is find the number of atoms on each side. So in this case we have 2 hydrogens on the reactant side and 2 oxygens on the reactant side and 2 hydrogens on the product side and 1 oxygen on the product side. And step 2 says that identify an element that is not equal on both sides. So oxygen is not equal on both sides because on the reactant side we have 2 and on the product side we have 1. So in order to fix that, we're going to write our equation first, rewrite it so we know what we're doing. Alright, so we have to fix our oxygen. So on this side we need 2. So in order to do that, we're going to have to add a coefficient here because we can't add a subscript. So 2, that gives us 2 oxygens, but 4. So over here we would have 2 times 2 equals 4 for our hydrogens, and 2 times 1, which would give us 2 oxygens. So now our hydrogens aren't balanced. So in order to fix that, we'd have to add a 2 over here, and that will give us 4 hydrogens. 2 times 2 equals 4, and 2 oxygens. And now our equation is balanced. Alright, and our second example, we have N2O5 yields N2 plus O2. Alright, and this is a decomposition reaction because it breaks down into one product, breaks down into 2 or more products. Alright, and step 1 says find the number of atoms on each side. Again, we have oxygen is not equal on both sides because we have 5 oxygens on the reactant side and 2 oxygens on the product side. Alright, and in order to fix that, we're going to rewrite our equation down here. Okay, so in order to fix this, we need to add a coefficient. So we're going to put this number over here. We're going to change the subscripts, which would give us N2 and 10 oxygens. And over here we have 2 times 2, which equals 4, and 2 times 5, which would give us 10. So now our oxygens are balanced, but our nitrogens aren't. So we have to add a 2 to this one to get that balance. So 2 times 2 equals 4. And now that's balanced as well.